We get a Jamestown today, but it's not due today, it's due tomorrow. Yes. Yes, Tyler. Yes.
What?
It's always like that.
What? Is it the SAT one or is it the
SAT or ACT prep or whatever it is.
That's not a Jamestown.
Yes, it is. She calls it a Jamestown, Tyler.
Well, what kind of recipe? We always have to do it.
I think of the fluency one.
I think of the fluency. I'm just not gonna ask you anymore. You're making absolutely no sense.
Tyler.
Neither do you.
Just go along with the flow in class today, and I'll make 100% sense.
You're killing me, Connor. I'm not gonna ask you.
You don't have to look at Connor, so.
I don't.
Jonas.
He's actually looking
With
for
you,
it.
is this week's student? No, it's not.
Yeah, it's
2-9.
It's the middle.
So,
Sherwood, or not
so tomorrow.
Did you not?
It's in the middle of November.
Sherwood.
Schedule
No,
is
that's
around practice like anyone. You know, like,
Tyler,
It's in the
not
middle of November.
No, it is the middle of
And
November.
I said 3 weeks from today.
Let's do nice the beginning of every month. It's the
That's
middle.
what. That's what I asked you. Says you're in the middle of
Whatever.
November. You get
It
one.
is the middle of the month right now.
Shut
up.
It's the middle of the
Yes,
month.
I know.
Alright, can you get it now?
Yes.
It was really easy, like, you know how we like
I only
run
did that
fast
when I
break
get past this.
and go through the options?
Wait, where'd
We
you go?
did like how to cover on defense. It was super easy.
Go down.
And then we ran plays. Which you know the plays. So.
Okay, alright. Today, homework, we have page 284 that was due at some point today. So if you have that done, at least get it in at some point, make sure your name's on it. If you're going to turn it in later, for the love of God, put a period number on there, like, oh, you're period 3, you're period something, you're period 4, whatever you got. Okay?
Yeah, Korean. Yeah.
What?
Korean fixed assignments in.
You got late assignments, you got redos, you got whatever you got, turn them in. That's what I want.
So I found one in my folder that was from like a first nest. I can't read it.
But I-
No. Pass quarter.
Serious.
That I do know. That I.
That's a second try. Questions like
So,
those.
No, if it's, hey, if it's in the grade book right now, is it, hey, if it's in the grade book right now as an N, you can turn that in. Okay.
I don't have Snickers.
Is he making us go to another yard of them?
Yeah, they're all
And then he
gone.
gets about time.
Okay.
They're all gone.
Yeah, I sold them.
Oh.
$1 a pop.
All right. Let's see. Who the other? Who's over there?
That's tomorrow.
Is that it? All right, good. Got everybody. All right, today we're going to continue on with the PowerPoint that we started the other day. Just kind of a rough PowerPoint where it's just kind of allowing us to go through story problems, story-based problems on this particular section, this unit. So again, the section we're on is section 2.2. Today we'll kind of do some hands-on problems where I'm going to have you move around, kind of price them out. We did 2 problems yesterday. We did the one where we had to find like a pair of numbers that would give you the smallest product known. And there's a certain stipulation to those 2 numbers. We'll try another one of those out today to kind of see if you get kind of back into that. And then our goal is to do a couple story problems on something that's more applicable. So something that's for like a farmer or like a business, that kind of thing. And I picked a bunch of problems. I picked some from the book and I kind of modified them so they can make more sense. Polynomial rational functions, that's our section we're in right now. So our goals today, we're going to go through review quadratics, but we're going to be doing problem solving. So practical application. This is kind of the same stuff we started yesterday. But I thought this stuff is kind of nice. You can kind of see why we're learning certain things from like this assignment over here. That process of like completing the square can actually help us solve story problems. So it's actually just an easy way of doing a problem, especially if you have decimals and whatnot. So you'll definitely need a calculator today. Now, homework due today, page 284. Make sure you get that turned in. When you're graphing, you only had to put those on the notebook paper. You didn't have to have a separate graphic for those. But again, you did have to do the quadratic equation for these last couple to see if they hit the x-axis because you had to find the intercepts, the vertex, and you had to graph that. Completing the square is required for the vertex. And you had to find the intercepts for that whole process for that. So that was only the last couple. These first ones are just like add, subtract, multiply, divide, imaginaries. They're super easy, those first couple. Questions on 284 that was due today? Alright, so at some point today, if you're in later, please God put a period number on there, like period 3, period 4, whatever that is. Alright. Okay, now again, I picked another problem from the book, kind of the style. These are the problems around there, about 63, 64-ish, from page 300. These are the types of problems we saw yesterday. Okay, so here's an example. I just picked another one here. All the pair of numbers whose sum is 12. So we're going to sum the numbers and they give you 12. And we want to find a pair that is as large as possible. Okay, find the product, or find the pair of numbers whose product is as large as possible. So a maximum number for the pair. Okay, so now here's the thing. Do we know the numbers offhand? Do they give us the numbers? No. So we have to create a variable, right? That's how we start these problems. So we'll pick a number for the pair. So we'll pick for the first number, we're going to call it x, right? That's the first number in the pair. Okay? What would the other number have to be? It's actually 12 minus x. Because the numbers have to add up to be 12, whatever they are, right? The numbers have to add up to be 12. So let's say that number is 5. The x is a 5. And that means my other number has to be 7. Right? So it's this idea that it's whatever the other number is, it's 12 minus the original number that we chose. Okay? So does everyone see that those are going to be my two numbers? So they put a limit. The sum was 12, so the maximum number we can have is we have to have 12 minus the x. And now what we're going to try to do is we're going to try to find the product of these numbers. We're going to try to figure out the maximum numbers, the maximum product that we can get. So the first thing I want to find is the pair. The second thing I want to find is what is the actual number that they're going to multiply out to give me. Now the biggest number that they're going to give me. Hopefully they can give us a positive number. That's the idea. Okay? Alright, questions, comments on what these are. Alright, so let's start with this problem. How I find the product. Product means what again? Okay, we'll multiply them together, and this is going to equal my function. So let's actually multiply that right side out there. What is it when I actually multiply this out? All right, minus x. Say it again. All right. Okay. Is there any numbers I need to drag to the other side with the y, like completing the square process? No, because it's like a 0, right? So there's nothing to drag over. I'm going to rearrange that right side here, so it's a little more familiar to us. So I'm going to rearrange it like this. Okay, any questions with that so far? Okay, so now that we have that, we've rearranged. I'm going to factor out the number that's in front of my x squared. What's the number in front of x squared on this particular problem? The -1. I need to factor that out. Because remember, you can't leave a number in front of that variable. So I got to factor out the -1. So if I divide a -1 out, that's x squared. And if I factor out a -1 here, that's a -12x. I'm dividing that negative. Okay, questions, comments on how I did that?
So if there's nothing in front, you take out a 1.
Yeah, you wouldn't even have to do it because it's a 1, 1 goes to the other. So if it's like a 2, you take out 2 and go.
Oh, this is
That makes sense? So you're dividing out. No matter what it is, if it's a 5, you take out 5, you take 12 divided by 5. Okay? Alright, so now that we're here, now what we need to do is we need to take half the middle, 6 squared, 36, right? And whatever that is, we take it times the number out front, which is -36, and that's what we're going to put over here. So it's half the middle squared, whatever that is. It can be a decimal, it can be a fraction. If it's a fraction, I leave it a fraction. We square it, you take it times the number out front if there's a number sitting there, and then you put it on the other side. So I took 36 times -1, that's why it's a 36 on the other side. And now I can factor up that right side. So that right side can actually factor apart. Let's see, what do we got? We got in the shortcut that I told you, it's going to be x, it'll be this symbol, and it's always half the middle. 6, and that's squared. That's how the trinomial would work. It'd be x minus 6, x minus 6. So there's two other parentheses. So what is my vertex on that problem? Yep, 636, right? This number is the x number of your pair. It's that number up there, that original number we created. This number here is the product you're going to get. It's the largest number that you're going to get when you use these numbers. And that's the idea. How I know the y number is the product is because that's what it represents. It represents these two numbers multiplied together. That's a y. So that's why it's the product. So this is the actual answer for what you're going to get when you multiply. This is the first number. So this will be the 6. What would the other number have to be? 6. So that's your pair. It's actually 6 and 6. Actually the same number. Okay, question.
This was the -1 or negative sign from the
Yes.
1.
Yeah. And just knowing that, this is the reason why this problem has a maximum, like a maximum product. Because when you look at that little -1 that's out front, that means my graph is going down. If you were to actually graph this thing. So if you were to graph, over at 6, it'd be up at 36. That's the actual vertex, and everything's going down from there. That's why that's the maximum value. Okay, questions, comments on this problem? It's a lot like the one we did yesterday, but I think yesterday they asked for like the minimum number. And the reason why they're asking for a minimum is because they knew when they multiply these two numbers together, when they multiply them together, that was going to be a minimum number. This is the graphic one. Okay, questions on that? I think that's pretty easy. Now, the reason I brought this one up and the one I did yesterday is because this gets us into that mind frame of like what we need to do, like this concept of that we're going to be multiplying things together. If it's a story problem with some business, there's a price and a number of customers, so you're trying to find the total price, that type of thing. But this is the process we're doing. We're always completing the square, we're trying to figure out the actual value. All right, so let's try a couple out. Now, here's my question to you. Do you want to do a business problem again, or do you want to just go into like maybe we'll do like a farm problem, we'll come back to a business problem later? Farm. Okay, do one of those. So I have a bunch of slides here, so I can kind of pick from them. I'll do the first one. I believe the first one is a farm question. So, yeah, and this the type of problems I was picking from. I was going to look at the problems. Okay, so you have 800 feet of fence around that encloses a rectangular plot that borders a barn. So you do not fence the side along the barn itself. Find the length and width of the plot that will maximize the area. So this is what a farmer would do. They're trying to maximize the little pin, the area for their animals. So they're putting a fence line in there, and there's 800 feet of fence. That's the idea. You want to maximize area. So what would the largest area be? That's the idea. So we want to know what will that area be in this problem? What will the dimensions of the actual farm be? Okay, does that make sense? Like what we're going to be finding here? I'll draw a picture here, but this is the idea. So here's my barn, and we're going to be putting a fence basically along the barn going this way, and this way. Does that make sense? Like that's what we're doing. We're using one side of that barn. Okay, now how many feet of fence are we using? 800. So that's got to be a number we got to think about. There's only 3 walls here, but we're using 800 feet of fence. Okay. All right. So now how this works? Since it's a rectangle, these dimensions have to be the same, correct? Like that fence line. So whatever one of those dimensions are, that's x. The other one is also x. What will this number be? The same length as the side of the barn. That's good. But in terms of fence line, how much fence do we have left? Minus 2 of the x's. So you're actually right. So it's the same length as the barn, which I agree with. But the actual dimensions for the fence is the 800 feet of fence minus the 2 x's. That will give me whatever's left over for that 800 feet of fence. Does that make sense now? Now, how we're going to do this problem? How I know that I want to find area for this area for this pin where all my animals are going to be. How do you find area of a rectangle? Say it again. Length of its height or base of its width, length of its width, whatever those dimensions you want to call it. I'm going to take this item So that's going to be my formula right here. I'm going to take the x times that 800 minus 2x. Make sense? Like that's how I'm going to find the area of this here, this pin. So I had to draw it, kind of visualize what that was going to be. Okay, now questions, anybody, does anyone have a question like the dimensions I picked, how I did it? Like for me, like when I was doing this problem, I had to draw it. I had to first draw it. I would never be able to figure that out without drawing. Okay, question. Okay. All right. Any questions in the back? Can everyone see this on the board? Do I need to turn on the lights? See it? Okay. All right. If you can't, let me know. I can't get a feel for how dark it is. All right. So let's actually do some of the math here. It's basically the exact same thing with the last one we did. Just there's some bigger numbers. Because we're dealing with area, and that's a very large piece of pencil. So we're going to distribute. Yep. Y equals 800x minus 2x. Okay, so I distribute the x. I'm going to rearrange this problem like we did earlier. So y equals 2x squared plus 800x. And now we're going to start the process of, actually completing the square on this particular problem. Use a green color. My green color is definitely not going to show. Okay, so I have to factor out about the -2 there on this problem. And this is actually why this problem has a maximum. But looking at this right now, this thing is most definitely, the graph is most definitely going down. So this graph has a maximum to it. That's the negative sign telling me that. All right, so I'm going to factor out the -2 here. Let's whatever the number is out front. So I'm going to factor that out. So what am I left with in here? X squared minus 400x. Because I'm dividing by -2. I divide this by -2. I get that. Okay, questions on that so far? Hopefully I haven't lost anybody yet. All right, now half the middle, 200, and we have to square it. So that's 200 squared. Right? I have to take this number times the number up front, which is what, -80,000. That's what I'm putting on the other side. Because it's half the middle squared times the number up front, because that's, if I distribute it, that's actually what I'm creating. This is the number I'm making up. And that's what I have to add to this. If I'm making up a number, I have to add full steps in the equation to make sure it's balanced equation. So making sure they're putting 80,000, because this number is actually 80,000 if you actually distribute. And now I'm going to factor this set apart. The other side's already kind of done. I don't need to combine anything over here. And if I factor this side apart, it's what, x minus, what's half the middle? 200 minus square. That's just kind of a trick. That's how I always know what's the factor. I think it's always half the middle. So that's how we create this. Half the middle squared. And now what's my vertex on this particular problem? 200, comma 80,000. Now what this represents? This represents the x coordinate for my barn, the actual picture over there. This represents the area. And this area is in feet, so square feet. It's 80,000 square feet. Yeah, that's the idea. So this is the 200 feet for my x. So if I go over here, this is 200, right? 200, this is 200. And that means that this dimension over here is 800 minus 2 times 200, so that's 400. 800 minus 400, this would be 400. So that side of that barn is 400 feet. Plugging the 200 into the x's on my picture, and I can get kind of a dimension of what that picture is going to look like. Make sense? That's using all 800 feet of fence. questions, comments on anything I've done here? This type of problem, like maximizing, minimizing. Do you notice how they're always like the same problem? Multiplying things together, you can square. Just figuring out what those dimensions are takes like you need a picture to kind of figure that out. Okay, we might come back to this idea of a fence line here. Let's do a problem where we go back to a business, like where we're going to increase prices on tickets or whatever. So, or create our own problem where we have a product where we increase prices on it. So in fact, I'll let you guys kind of create a business. Let's come up with a product you want to sell. We'll make up some numbers so you can kind of get a feel for it. And we'll come back to the PowerPoint and we'll try a different one. Okay? So, business, what do we got?
We sell clothespins.
Clothespins. Okay, so that's fine. We'll do that. All right. In fact, let me get rid of this picture. All right, so we're going to sell clothespins. Kind of weird business. I'll go with it. All right. How much do we want to charge for our clothespins?
$7.
Seven.
Seven.
All right. So $7 for our clothespins. So this is going to be another business venture. All right, so clothespins. And we're charging $7, you said? Now, how many customers do we normally sell to a month? 14? Let's go bigger. 50,000.
Not many people like us even know what clothespins.
All right, how about we go, let's go 150 customers. So let's say maybe customers bought 15, okay? $14, about 150. So let's start customer base. Okay, make sense so far? Now, why I need to know that? Why I need to know like the customers that are purchasing them and how much they are. If I know like a customer's going to at least buy one of our clothespins, I can get kind of like a minimum number, like a price that I'm going to make off our customers. So this is just taking your price times how many customers we have. This would be like the minimum amount of money that I can make off our customers. So 7 times 150, 1,050. Okay, so that's how much money we're potentially making as a minimum if they buy one of our clothes. Seems like a little expensive, but we'll go. Okay? Now what this problem's going to do, I want to maximize like the price on my clothespin. So I'm going to start increasing the price of the clothespin until I know certain customers won't buy any of those, but we're going to try to figure out that happy spot where I can maximize the profits of my clothespin, like the price on it, and maximize like how many customers are willing to buy it. So let's say for every dollar I'm going to increase by. So I'm going to increase my price by so many dollars. I'm going to lose 5 customers. Now let's do that. So every dollar I increase my clothespin, I'm going to lose 5 people that won't buy me. Nope, not going to do it. So 5 people are going to lose interest. So that means out of the 150, I'm going to lose 5 people for every dollar I increase. Does that make sense now? The X represents the dollars, so if I take the number of dollars times 5, that will be how many people are leaving my business that aren't going there. And what I'm doing here is I'm actually multiplying them together. This will give me like a maximum profit. This is how many dollars I'm charging for, this is how many customers I have, that gives me my minimum kind of profit. But I could potentially make that at least by 1. Okay, does that make sense over here, what I'm doing? I'm increasing my price by dollars, I'm losing 5 customers every time I do that. And that can be any number, we can just make up a number. Maybe 10 customers are leaving for every dollar. But this is like hypothetical, what you're thinking will happen, or maybe you did a survey. Alright, so now that we have this, this is my function, and we're just going to solve for outcome. We're going to multiply this, solve for do the completeness square, and we can figure out our vertex, and that vertex will actually give me my X number, which is the dollar I'm increasing by, and it will actually give me what my profits are. Because right now, potentially I'm making about 1,050. That's roughly what I'm making right now, off my 150 customers. Alright, so let's actually distribute first out here last. What do I get? 7 times 150, 1,050, so double check that. And then 7 times negative 5 is negative 35x. X times 150 is 150x. And x times negative 5, x is negative 5x. Okay, that's foiling first out of here. Okay, So let's kind of rearrange here. I want to get, the plain numbers to the other side of the y, because I don't want those. So I'm going to move that 1,050 across. That's negative now. Over here, I have the negative 5x squared. But what did these add up to be? 115, right? Yeah, 115. Okay, questions, comments on how I did that so far? Like, I combine like terms, move the 150 across, or 1,050 across. Okay, what do I have to do to complete the square? I have to get rid of the 5. So I'm going to factor up the 5 in front of the x squared, because that's kind of what we did over there. Factor up the negative 2. I'm going to take out the negative 5. So if I factor that out, that's x squared. Taking out a negative 5 here would be negative. That's 2. 25? 23? Okay. Oh, here. All right, so 23. And I have the blank there, and then over here I have a y. All right. Questions with how I factor out the negative 5? Any questions with that? Okay. Now, this is where I definitely need a calculator. We're going to take half the middle. So 23 cut in half is like 11.5. Okay, that's half of 23. And we have to square it. So we can do that. We're getting dollars. So it doesn't matter. If we want to do fractions, I'm just going to do dollars. So 11 and a half is 23 divided by 2, and I need to square it. 132.25. I have to take that number times the negative 5 out front. Negative 5 times that.
Negative 661.
0.25? Yep. And that's what I'm adding to the other side. So this is half the middle, which is 11.5, squared times the number up front, put it on the other side. That's what we did over there as well. Half the middle squared times the number up front. And what this should make on this left side here, this left side over here, I have, let's see, 5, 2, 1, 1, 7, 1. Yep. So it's $1,711.00 equals, and on this side I'm going to factor this apart. Factoring that apart, that's always half the middle, so it's 11.5 squared. And what this is giving me now, it's giving me my vertex on this particular problem. So what number is the vertex? 11.5 and 1,711. All right, now what this is doing, what this vertex is, the x, this is my x. This is what you should increase your clothespin price by.
5 or 2?
By. You need to increase your price. It was $7. You need to increase it, go up $11.50 more. You're probably going, whoa. Because if your customers hold to what their survey said, so now your price is going to be $18.50 per clothespin, right? You're going to make a maximum profit on this problem. You're going to make about $1,700. $1,711. You were making $1,000, but just increasing prices, you're losing some customers, but you're making more money in the long run. That's the idea. That's a big increase. The reason why this is a big increase, you don't have a lot of customers, so you increase it a lot. The more customers you have, the less you have to increase by to get kind of profit. All right. Questions with that? How we did that problem? That could be for any business. You increase a price, or decrease a price, or figure out where your profits are going to be. You just have to kind of get a feel for how many customers you'll lose. So maybe that takes a survey. Maybe that's just experimenting, like changing prices in the store and seeing what happens, and seeing how your month-to-month changes. They can get kind of feel like, oh, I lost, I didn't sell those, I didn't sell 5 of those because they increased by $1. That type of thing. All right. So here's the question: do we want to do a barn problem, or do we want to do one of these again, or we do a business? I'm going to do one more, just one more thing. Business. Okay. I'm going to create the business one. So I'm going to create one. I'm going to do something that's a little more realistic, a little more different than this one. I'm going to go different. Okay. All right. So same kind of concept, but I'm gonna go bigger numbers. Like 7.
Let's not go for numbers, my comments.
I noticed. All right, so let's do another business problem.
What was Jade had number when he was like minus 47?
All right, so let's see now the balance. The playground. I don't want this playground. Yeah, here we go. Here's the business problem. Okay, so it's an airline pilots. All right, so this certain airline gets about 8,000 passengers, per month. So each paying about $60. So we can get kind of a profit for what we can get for our customers. We're willing to increase the dollars of these tickets, and for every dollar increased by, we're losing about 100 people off of it. What we're trying to do is we're trying to maximize our airline's monthly revenue. So it's kind of like the last one we just did, but we're losing way more customers. Not 5 customers, we're losing hundreds at a time. Make sense? Okay, so now, think about this like logically. If each of our customers are paying $60 and we're getting roughly about 8,000 customers, when you actually multiply this out, let's see. This is roughly the money we're making per month. That's taking 60 times 8,000. So 480,000 bucks. Okay? Does that make sense? Like what we're making right now? But we want to maximize it. We want to see, can we? I know we're going to lose a couple customers, but can we get our revenue up a little bit? Can we make a little more money? So we're going to start increasing our ticket price. Now we don't know how many dollars we can increase by. So we're going to increase by X. X is going to represent our dollars. Correct? Now for every dollar I increase by, how many customers am I losing? 100. So I'm losing 100 people for every X. For every dollar I increase by. So if there was $2 I'm increased by, I'm losing 200 people. 100 times 2. Okay, does that make sense? Like why I put 100x? 100 dollars times the people I'm losing per dollar. What this is going to do, that little product there, that is finding my total revenue. Like I just did over here. I multiply the price times the customers. I use the amount of revenue.
But you get 100,000 minus 2.
Okay. So they said, 50 people with 50 instead. This is going to be my function. So we're going to do a little bit of math here. We'll kind of FOIL out.
May I have your attention, please? Any juniors or seniors that need to see Joe from Athletico, please go down to the locker room area at this time. Thank you.
Okay, so let's take a look at this problem. So let's FOIL this out. So if I FOIL first, enter last, 480,000, 60 times 8,000. 60 times the 100 is 6,000 x, negative 6,000. X times 8,000 is 8,000 x. And x times negative 100, x is negative 100x squared. Okay, questions on how I just started that from, how I FOILed everything together? Usually people always don't follow that much. Let's move the 480,000 across. So that's negative 480,000. Over here, I'm going to kind of rearrange this stuff because this moved over. But over here, the negative 100's x squared by itself. These add together to make what? 2,000 x's? I add those up like terms. So now, what do I need to factor? 100 out, negative 100. So when we take out the negative 100, taking out the negative 100, I'm left with an x squared here. Factor out a negative 100 there, that's negative 20x. You know, 100 out of 2,000. Okay, questions, comments on how I just did this so far? Okay, half the middle, please. Okay, so 10 squared, 100. So it's half the middle squared, and when you square it, turn positive, right? Take 10's number up front, so that's, what is that, 10,000? Negative 10,000, and that's what I'm putting over here. That is 100 times 100. It's negative 10,000. Now, factoring this apart, this should be my last couple of steps here. This side over here, this is a negative 490,000. So, what's my vertex on that particular problem? 10, comma? This, right here, this is the X you should increase your ticket by. This is your revenue. So if I increase my ticket price by $10 now, I'm going up to $70 for a plane ticket. That'll maximize my revenue. After that, I'll start losing money. I'll lose too many customers and I won't make profit. I'll start going down. So it was actually pretty close. I didn't have to increase by too many. It wasn't like the last problem, right? More people usually don't go as far for a certain customer. Okay, makes sense? Okay, that's my last problem of the day. That's all I want to cover. Tomorrow, I want to do another farm problem where we maybe change the fence line on something, because of area and stuff. And then we are going to get work on this stuff tomorrow. We are going to get some straight problems. Not a lot. I think I picked out maybe 10 problems already. Okay, but that's it for today. That was pretty good. If we need to, we'll make up our own problem for us tomorrow. I thought these are interesting. They're kind of fun. I like them.
I'll probably get
So you were wrong from the start.
I don't even know, your parents have to be like,
Yeah, it is.
see you next year, am I right?
Oh.
Nothing happens.
Here you go.
Right there?
Yeah, I said that. Check these.
Right. And then you get another one like that. That is graded.
Wait, when?
In English.
They're not graded.
No. Nope. Those things that we did, those like 4 or 5 exercises that we did, they're not graded. But then we get one today that we have to turn in before the unit class is graded. Kind of.
Basketball going yesterday.
Ours?
Yeah.
Great.
Great. Like it is freaking personal.
Are you tired or something?
Yeah, I'm like,
It's just, I
I don't know. You slept in this morning, so.
You got 10 minutes.
Well, I tried calling you and it didn't answer.
No. Do you think I can be late? My alarm went off at 5. Well, the song is playing, you know. I just didn't turn it off until like 5:30. I just laid there with that line.
Alright. Good.
Big lows.
Never, it's a second shot that
It's
counts.
bad to set sounds you
Second
like as
semester.
a
All you that.
Yeah, I'm learning to hate that song right now.
Better extra teacher.
Everyone has to have fun holding them and make sure they wake up. And I called him at 5:20 yesterday. He was never happy.
Really quick.
Yeah, and then I called him
We
at
had
5.
practice start at 6, didn't you?
Yeah,
5:18.
Hey, you didn't even answer that.
Yeah, good. I was sleeping.
Tomorrow it's gonna be 5:15.
No, don't, please don't.
I'm gonna.
Just answer.
It is my
No,
duty as a
this is like
teammate.
Yeah,
to
we
call
all,
you.
every
Make sure you're
every
up.
player has like a person that they should call the next day. And I'm Jack, and apparently Jack wakes up at,
Is it great?
I wake up at 5:15.
yeah, he calls me. Ray wakes up at like 4 o'clock. He's the person
Actually,
I
I
didn't even
have
call
a
him.
rated practice today.
I didn't even call him this morning, I knew he'd be there.
I was there so early.
This
Locker rooms weren't even open yet. I
What's
couldn't
the
change
second
it.
shot?
A number out there.
What do you guys do? Looking out the gym?
Yeah, I tried to check all that.
I'm thinking about like
I was
going
there
early
for-
tomorrow, like 5, bring a blanket, hello,
Just
lay on a bench in the locker room.
I was there for 15 minutes.
Remember I got,
before the
I
lost.
had a terrible.
I just said,
Oh.